this week, uh, hello. First, value function. This is going to families of general stuff. Now look at special stuff to deal with all these work. Starting with absolute value. So, for starters, what does the graph of that look like? Okay, it's an absolute value function, which means it looks like what? Shape graph, shifted 2 to the right and up 1. So the vertex, the corner point of that shaped graph is where now? Okay. 1. My drawing's not perfect, but something like that. Okay. And for absolute value functions in general, of course, we remember stuff about how they behave. They're defined everywhere. Change something like that. This one in particular, we've shifted up, so the know what the graph looks like, then we can solve stuff like this. Am I giving you X or Y here? We've got a spot for an unknown value of X. So that must be what we're looking at. Means I'm telling you Y. Given Y, which means our job is to find X then. Okay, well, if I have a nice graph of this thing sitting there, what do we need to look for? Find Y equals 3. 1, 2, there it is. Then what? Yeah. Find the X or is to go with that. What are they? 2, what are they? 0. No. It's the symmetry. Yeah. Because what an absolute value does is tell you how far away you are from something. Something else is both those value. That means that's what's going on. So if we solve an absolute value equation, we should kind of go in expecting that we're probably going to find places where that. Okay. I'm going to jump around a little bit. We'll come back to that in just a second. Let's take a couple of minutes and you guys try a couple of these. Okay. A, we should pretty much be able to look at it and write down an answer. Right? Where's the absolute value of x equals 5? What is a number that is 5 away from 0? 5. Or negative 5. Absolute value of 5 is 5. The absolute value of negative 5 is also 5. Okay? Well, B looks a little bit different because there's that plus 1 there. But can we make it look more like A? Sure. How? Subtract 1 from both sides. Get the absolute value term by itself. Now it looks more like, hey, I want a number whose absolute value is distance from 0 is exactly 2. That would be 2 or -2. Okay? Now we're just listing them. Yeah. So if no, it doesn't matter because C, what's different? It's the +3 thing. Let's not worry about it yet. What can we do with that -2? Same kind of thing we just did. Move it to the other side. Get it away from the absolute value. Okay? So the absolute value of x plus 3, 6. About that yet. The absolute value of something, distance from 0 of something, is exactly how much? 6. Or exactly 6 away from 0. Where can you 6, -6. Okay? So whatever this thing is, it could be 6, or it could be -6. Right? Okay. Well, now let's, look and see what it was. Oh, okay, it was x plus 3. So we have a little bit more to do. Find x. I know what x plus 3 is. So what do we do? Subtract 3. So x is 3 or 9. Got one additional layer of stuff to worry about. Idea what by 2 value term by itself. Saw this a little. I'm not at all concerned. The absolute value of x plus 3 is add 1, you get 8. Divide by 2, you get. Tells me that either x plus 3 is 4 or x plus 3 is -4, 1, -7 are the two solutions of values. Okay, so that's About inequalities then. For two things to be equal. They're exactly the same. Exactly the same. So what did we look for on the graph then to find where they were? Any points y values exactly the same, right? We looked for where it passed through that height, where it was a 3. Okay? What does an inequality mean? Yeah, it means they're not the same, but they're not the same in a specific direction, right? I mean, if we're comparing numbers, there's only 3 possibilities. Either they're the same, bigger, the other's bigger. It, remember how inequalities work? Like a shark wants to eat the bigger thing, right? Okay. So this says that this is less than. If I'm looking about or thinking about it graphically, what does less than look like? Imagine, moving a point along this graph and sort of picturing the coordinates to write them out. But right here, whatever the x value is, the y value is, I don't know, about 4, right? Smaller than 3? No. Right here, y value is exactly 3. Smaller than 3? Right here, the y value is 2. 2 smaller than 3? Yeah. Here, smaller, 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 smaller. Here, exactly 3 again. Here, bigger than 3. Okay, so what this does then, what we're kind of looking at is to answer the question, where is this less than 3? It's like if I'm moving along this graph, what I want to know is what part of the graph, what subset of the domain of that function does it dip below that pink line? So if, riding on the roller coaster track of this function, left to right, where does it dip below that pink line? You get to 0, then you got to be careful about. And where does it get back above the pink line? 4. And then after that, you're above again. So all out here, function sitting above 3. Out here, it's sitting above 3. But this chunk in the middle, sitting lower than 3. That's the part we're interested in because the question was, where is it? Everything. Dips below at 0. So the way I write my solution then is as an interval. 0, again, this is the normal like, interval notation sense of everything exclusive all these the other everywhere else. How would I write everywhere else? Negative infinity to 0 and infinity to the other side. Because bigger or small. Okay, so solving inequalities. That graph. Test it numerically. Do one quick. The absolute value of x is equal to 5. What could x be? Negative 5 or 5. Okay. What I want to know then, I'm not going to graph the whole thing. I'm just going to write the, going to give myself like a number line axis just to kind of keep things organized. Mark negative 5 and 5, negative 5 and 5. And what I've just learned here is that these are the two places where value roller crosses through. Those are the two places. What I want to know is where they're not the same, but in a particular way. So I can either think about it graphically, and if you have a good mental picture of what an absolute value function looks like and what 5 would be, and you know how you decide greater than or less than based on sitting above, that's awesome. Go with that. Draw something, you know, like that to maybe how you're thinking about it. That absolute value function looks like that. It crosses through 5. So if we want to know less than, be less than in between those 2 points or outside of them. Because it's sitting below. If you're less comfortable with it, another way I could do this so should I include anything from this interval? No, because stuff in that interval is not going to give me a true statement here. it's not going to be smaller than 5. Everything out there is out. If it doesn't work for -6, I solve the at 0. Zero and anything like it, thing in between -5 and 5, to satisfy that inequality is going to absolute value of 6. Oh. So our solution set looks like this. Less than, so should open. That stuff. Yes, brackets if they were included, and the way you would tell that is if because at those endpoints they are equal, which means if I plug 5 in here, asking is 5 smaller than 5, the answer is okay. This thing again, if a little bit being able to kind of okay. We already did skip around a little. Talk about D first. This is the same statement as part D in number 2, with an inequality rather than an equality. So we already did the first part. Got 1 and -7 as solutions to the equation there. That means that -7 and 1 are going to be important in solving the inequality. Well, that tells me the cutoff point where these things we also did the sort of thing down to that. That all happened in 2D, but that's what you would do. So what I need to test around are -7 and 1. That gives me 3 sub-intervals, 3 chunks, stuff that I need to make a decision about. Somebody give me some value that's to the left of -7. Okay. and something between -7 and 1. Okay? Something to the right of 1. 2. Okay. Y'all, this column of people, y'all test -8. All we're doing is plug deciding, yes or no. Okay. Absolute value of -8 plus 3. -8 plus 3. Okay. So is 5 bigger than 4? Yes. Okay. Guys, absolute value of -3 plus 3. 0. Is 0 bigger than 4? 7 plus 3. Okay. 10. 10 bigger than 4, yes. So what's the solution set then to this inequality? Okay. Endpoints should be closed because okay, cool. There are several more there that you should try. For class. One way of thinking about an absolute value function is as an example of something we call a somebody give me just yeah. It's 2. Graphically, piecewise functions look strange then. Okay. That's it then. So we just go look them up, we figure out what they are. What's f of -3 for 5? Because when x is -3, there you go, f5. The thing that we maybe need a little, that we really need to concentrate on or figure out, the way you write a piecewise function, still a function, it still gets a name, it's still equal to whatever. So f of x equals, in kind of usual way. But this big brace, really braces like that, that always. This part tells you what the rule, the operation, the form, and like the usual. Got X in it somewhere, probably you plug into it. Do this part tells you when to use each. This is what to do. This is when to do it. Do this when X is even. Than you should have. Watch, I could, income tax or something. Pay this much when your income is in here and here. Pay this much when your income like that. F of -3. What do we do? Yeah. Big picture, what I'm doing is plugging in -3. The new thing is that first I decide, well, which of these three things am I going to plug it in? So where does -3 fit? -3 is smaller than -2, so it fits into that first line, that first slot. So what's f of -3 then? 5. Okay, how about -2? First, which slot does it fit into? Second one. That's the only one of those that if I replace x with -2, that's the only one of those that would be a true. Right? -2 is not smaller than -2. -2 is not between 2 and 5. So I ignore those and just concentrate on this. Right? Okay. So I look at that, I decide, okay, I'm going to use this piece. Then f of -2 would be negative x plus 1. Guys, real quick, okay, plug in 1. That's where 1 fits. Right? Plug 1 in, you get 0. Okay. And D, we want to plug in 2. Where does 2 fit in? that's really pretty much it. It's kind of just about learning. Right. The last part, example 6 there, sketch the graph of the following. Do this one tonight. What you would do is just graph each of these 3 things separately and chop the ends off. Sorry. Take negative x minus 2, graph that, whatever it looks like. Chop the ends off at negative 5 and negative 3 of those, and you just sort of glue. Okay.